Ever wondered how live streaming works so seamlessly or how gamers experience minimal lag during an online match? Welcome to the intriguing world of UDP, or User Datagram Protocol, a cornerstone of the Internet's transport layer. This protocol is essential for applications that need fast, efficient data transmission, which is exactly why it's favored in environments where speed trumps reliability. UDP operates at the transport layer, or layer 4 of the OSI model, providing a connectionless service. This means it sends data without the need to establish a connection, allowing for quick data dispatch without waiting for acknowledgements from the receiving end. It's like sending a letter without needing a response that it's been received. This protocol's design is brilliantly simple and lightweight, contributing to its low overhead and high-speed capabilities. These features make UDP ideal for real-time applications, such as video streaming, VoIP, and online gaming. Stay tuned as we unravel the magic behind UDP and its impact on your online experiences. Scene script. Imagine sending a text without checking if your friend is ready to receive it. That's how UDP operates. In the realm of computer networks, the User Datagram Protocol, or UDP, is known for its connectionless communication style. This means that unlike its counterpart TCP, UDP does not establish a formal connection before data is sent. Each piece of data or datagram is independent and is dispatched without prior handshakes or agreements. This is akin to mailing letters without a return receipt. You send it hoping it reaches its destination, but without the assurance that it will. This method of sending data without establishing a connection significantly reduces the time it takes for data to travel from one point to another. By skipping the negotiation phase required by TCP, where connections must be made and maintained, UDP achieves lower latency. This is particularly advantageous in situations where speed is critical, such as live broadcasts or online gaming. Moreover, the overhead involved in UDP communication is minimal. While TCP carries out checks and balances, reordering data packets and confirming their delivery, UDP keeps it straightforward. It sends data as is, without adding much protocol overhead. This simplicity not only makes it lighter, but also faster in terms of raw data transfer speed. Yet, the lack of connection does raise questions about the reliability and order of data delivery, which are addressed by TCP but left largely unmanaged by UDP. This streamlined approach allows UDP to deliver data swiftly. But what about reliability? Not all packages delivered to your door are guaranteed to arrive in perfect order, or even arrive at all. This is a fitting metaphor for the User Datagram Protocol, or UDP, which is known for its unreliable delivery of data packets across networks. Unlike its more cautious counterpart, TCP, which meticulously checks that packets are delivered and in the correct order, UDP is like a carefree postman tossing letters onto your porch. It sends data without waiting to see if it gets there safely, or even if it gets there at all. This unreliability stems from UDP's lack of error recovery procedures. There are no acknowledgements if a packet is received, nor is there any attempt to resend lost packets. This might sound like a recipe for disaster, but it's actually by design. The protocol sacrifices reliability for speed and efficiency, which can be crucial in certain applications. Consider real-time applications like video streaming or online gaming. In these scenarios, receiving data quickly is often more important than receiving it perfectly. A slight glitch in a video or a brief lag in a game is preferable to waiting for delayed data to be resent. UDP's ability to send data continuously without waiting for previous packets to be acknowledged allows these applications to maintain higher performance and responsiveness. Furthermore, applications that use UDP are not left entirely in the lurch. They often implement their own methods of checking data integrity and order. This might include mechanisms within the application itself to reorder packets or recover from errors as needed. While this might seem like a drawback, there are scenarios where this is actually beneficial. Less baggage means faster travel. The same applies to network protocols. When delving into the world of computer networking, one quickly appreciates the elegance of simplicity, especially with protocols like UDP or User Datagram Protocol. Unlike its more complex cousin TCP, UDP is celebrated for its minimal overhead and straightforward header structure, which collectively enhance its operational speed. Let's unpack the UDP header first. It is remarkably concise, composed of just 4 fields: the source port, the destination port, the length, and the checksum. Each of these fields plays a critical role, yet their combined simplicity is a key to UDP's efficiency. The source port and destination port fields, each 16 bits in length, are essential for routing the datagrams to the correct applications on the sending and receiving ends. Think of them as addressing labels, ensuring that the data packets reach the right doorsteps. Next, the length field, also 16 bits, specifies the total size of the UDP datagram, including both header and data. This is crucial for the receiving end to understand how much data is expected, thereby facilitating the correct assembly of incoming packets. Lastly, the checksum. This field, though optional, is vital for error checking. It helps in verifying the integrity of the data as it travels through the network. If the data is altered due to noise or other interferences, the checksum will not match at the receiving end, indicating that something went awry. The brilliance of UDP lies in this minimalism. By stripping down to only what is essential, UDP reduces the data processing time significantly. This lack of complexity means that devices spend less time unpacking and more time transmitting data, which is particularly beneficial in environments where speed is crucial. Moreover, the absence of handshaking rituals like connection establishment, maintenance, and termination, which are typical in TCP, further reduces the overhead, making UDP an ideal choice for real-time applications such as video streaming, VoIP, or online gaming, where delay is a greater enemy than an occasional data glitch. This minimalistic design is what makes UDP the preferred choice for many real-time applications. Speed is the name of the game in many modern digital applications. When time is of the essence and each millisecond counts, UDP or User Datagram Protocol steps into the spotlight. This transport layer protocol is renowned for its ability to deliver data quickly and efficiently, without the baggage of connection setup and maintenance that TCP carries. UDP achieves this nimbleness by eliminating the need to establish a connection before data is sent. This means that data packets or datagrams are sent directly to the recipient without the preliminary handshakes. Imagine sending a text message without needing the recipient to confirm they are ready to receive it. That's UDP for you. It just sends the data hoping it reaches its destination. This characteristic is particularly beneficial for real-time applications. Take Voice over Internet Protocol, or VoIP, as an example. In VoIP, voice data is converted into digital packets and transmitted over the Internet. UDP's low-latency transmission allows these voice packets to be delivered swiftly enough to maintain a clear and stable conversation, almost as if it's happening in real time. Similarly, in video streaming, the quick data transfer capability of UDP minimizes buffering, leading to a smoother viewing experience. Streaming services can send video packets rapidly one after the other, and even if some packets are lost or arrive out of order, the overall impact is often negligible, resulting in just a minor glitch that's barely noticeable to the viewer. Online gaming is another arena where UDP shows its prowess. Gamers around the globe rely on UDP's fast transmission to keep their gameplay immediate and responsive. In a high-stakes game, the delay caused by waiting for drop packets to retransmit can mean the difference between victory and defeat. UDP ensures that the game's pace isn't compromised, maintaining an immersive and continuous play environment. Understanding these use cases shows us why UDP is crucial in a high-speed, connected world. Its ability to facilitate the rapid transmission of data underpins the functionality of many applications where speed and efficiency are paramount, making it an indispensable protocol in our digital age. So we've seen how UDP helps keep our digital world fast and connected. User Datagram Protocol, or UDP, stands out as a fundamental component in the realm of network communication, especially when speed and efficiency are at a premium. Unlike its counterpart TCP, UDP operates on a connectionless basis. This means it doesn't waste time establishing a connection before data is sent. Each piece of data, or datagram, is independent, which significantly enhances the speed of transmission and reduces the overhead. However, this speed comes with a trade-off in reliability. UDP does not guarantee the delivery of packets. It doesn't confirm whether data reaches its destination or rectify errors. Datagrams might arrive out of order, go missing, or contain errors, all without any protocol-level mechanism for correction. This unreliable delivery is a notable characteristic but isn't always a drawback, depending on the application. Speaking of overhead, UDP keeps it remarkably low. Its header is a model of simplicity, featuring just 4 fields: source port, destination port, length, and checksum. This not only contributes to lower data transmission costs, but also reduces the time taken to process each datagram, thus enabling faster communication speeds. These characteristics make UDP an excellent choice for applications where time is of the essence. It shines in scenarios like video streaming, VoIP calls, or online gaming, where delays are less tolerable than minor data inconsistencies. For such real-time applications, the ability of UDP to deliver data promptly without the burden of error correction and sequence control is invaluable. Yet it's crucial for applications relying on UDP to implement their own mechanisms for error checking and correction if they require them. This flexibility allows developers to tailor the reliability features to the specific needs of their applications, optimizing both performance and resource usage. In essence, UDP provides a lightweight, fast, and flexible communication option, making it indispensable for any application where speed trumps absolute reliability. Next time you stream a live event or jump into an online game, remember the unsung hero working behind the scenes: UDP.